All right, so your quiz is tomorrow on 5.1 and 5.2. I'm going to start with the 5.2 stuff, so the verifying questions. So starting with 13, I should have time to get through all of them, but I just want to make sure that we do the verifying because I think these are a little bit more tricky, and we kind of use the simplifying in these. All right, so 13. The left side looks a little bit trickier, so let's start with that. What should I do first?
Get everything in terms of sine and cosine.
All right, let's put everything in terms of sine and cosine. So tangent is sine over cosine. Remember, I'll give you the trig function or the trig identities for tomorrow, so you don't have to remember them, but just make sure you know how to apply them. Cosecant would be 1 over sine, and cosine is just cosine, but I'll put that cosine over 1. So I'm going to combine everything together. On top, I have sine times cosine. On the bottom, I have cosine times sine. What can I do next?
Reduce it to 1.
Awesome. Sines cancel. Cosines cancel. So I'm left with just 1 over 1, which is 1. So 1, which was my goal. Awesome. Let's take a look at 14. Any suggestions on how I should start 14? All right, let's FOIL. So if I FOIL the left side, I have sine squared times sine, or plus sine times cosine, minus cosine times sine, which is sine times cosine, because you can switch the order when multiplying. And then minus cosine squared. What can I do next? Cancel. So I have sine times cosine minus sine times cosine. So these are like terms here, so they'll cancel out. And then I'm left with sine squared minus cosine squared. Be careful, this is not an identity. Our identity is sine squared plus cosine squared. So we can't just cancel this out and make it 1. But looking at my answer, my goal is to get everything in terms of cosine. So that kind of gives me a hint that I'm going to want to change sine squared to be cosine. So I can use my identity here. I have sine squared plus cosine squared equals 1. So sine squared would be equal to, I'm going to move the cosine squared to the other side. So sine squared is equal to 1 minus cosine squared. So I'm going to take this and substitute it in for the sine. So I have 1 minus cosine squared minus cosine squared. What can I do next? Awesome. I'm going to combine like terms. So if I have a negative cosine squared and a negative cosine squared, how many cosine squareds do I have? 2. So this would be negative 2 cosine squared theta, which is the answer. All right, number 1 with our simplifying. What should I do first? Awesome. Convert everything to sine and cosine. So tangent would be sine over cosine times cosine over 1. So what happens here? The cosines cancel, and what am I left with? Just sine. So that would be my answer. So like sine and cosine are the basic units of trig here. So if you get everything in terms of sine and cosine, and if you get it to be like one thing especially, then you're done. So like if I had sine times cosine, I can't do anything else here. Like I could change sine to be 1 over cosecant, but it kind of just it makes it longer. If I had cosine times tangent, here I know I can simplify it more because tangent is sine over cosine. So not just getting it to be like one thing is the goal, but just get everything to be in terms of sine and cosine and as small as possible. So like another thing would be if you had 1 minus sine, just sine. So it's not squared. We can't use our identities here. But I also can't do anything else here. So this would be a stopping point too. So this one can be simplified more. These two are done. So that's just an example. All right, looking at number 2. What can I do here? Awesome. 1 minus cosine squared is one of my identities. So this is sine squared. So remember, sine squared plus cosine squared equals 1. So anytime you see like a 1 with a squared trig function, you're most likely going to use one of your identities. So we can manipulate this and get sine squared is equal to 1 minus cosine squared. So we know that 1 minus cosine squared is sine squared, so we just plug that in. So I have sine squared over cosine squared. What can I do next? Awesome. This is tangent squared. And once I get just one term there, I'm done. Any questions here? All right, number 3. What should I do first? Awesome. So I'm going to change cosecant to be 1 over sine. So then here I get cosine over sine. And what's cosine over sine? Cotangent. All right, number 4. What should I do first? Separate them?
Yeah, like do sine over tangent and secant over 1.
I could do that. Sine theta over tangent times secant over 1. What should I do next? I can change everything to be in terms of sine and cosine. So tangent would be sine over cosine. Since I have a fraction and a fraction, I can keep change flip. So keep the top, change the multiplication, flip the bottom. So that would be cosine over sine. If I have a sine on the top and a sine on the bottom, they'll cancel. So this is just cosine times secant, which secant I can change to be cosine. So 1 over cosine. And then they cancel. If I have a cosine on the top and a cosine on the bottom, this would be 1. The way I did this was right from the beginning. I changed everything to be in terms of sine and cosine, and then I keep change flip and did the same thing. Any questions here? All right, number 5. What should I do first? Put everything in terms of sine and cosine. So cosecant would be 1 over sine. Yes, cotangent is cosine over sine. Keep change flip. So I'm going to change to multiplication, flip the bottom to be sine over cosine. I have a sine on the top and a sine on the bottom, so those can cancel. And I'm left with 1 over cosine. And what's 1 over cosine? Secant. What should I do first? Yes. Awesome. I'm going to use one of my Pythagorean identities and make the numerator sine squared. Okay. What's tangent squared theta equal to?
Sine squared theta over cosine.
Oh, so you're using that one. So sine squared over cosine squared.
And I do like,
Keep, change, flip.
yeah.
So keep the top, change to multiplication, flip the bottom. If I have a sine squared on the top and a sine squared on the bottom, they cancel, and then I'm left with cosine squared on the top. So then that's it. What should I do first? So cosine theta times 1 over cosine.
Then that will cancel out. So you have 1 over.
So these cancel, and I'm left with 1 over tangent. And what's 1 over tangent? Cotangent. Good job. Good with this one? All right, 8. What should I do?
Cosecant to 1 over sine.
I can change cosecant to 1 over sine. Keep, change, flip. So change to multiplication. Flip the bottom to sine over cosine, or sine over 1, oops. Multiply. So this would be sine squared. Number 9. What should I do here? I can separate them. Since I'm adding, the tangent goes to both denominators here. So I have tangent theta over tangent plus cotangent over tangent. So because I'm adding on the top, when I separate them, that tangent goes to both denominators. Because if I add them together, the common denominator is tangent, and I just have one tangent on the bottom. So it's perfect. Tangent over tangent is 1. What should I do for cotangent over tangent? Well, cotangent is 1 over tangent. Then I can keep, change, flip. So keep the top, change to multiplication, flip the bottom to be 1 over tangent. So here I get 1 plus 1 over tangent squared. Can I simplify 1 over tangent squared? Yep, that would be cotangent. So 1 plus cotangent. Is 1 plus cotangent squared an identity?
Yes.
What's 1 plus cotangent squared equal to?
Cosecant squared.
Cosecant squared. Awesome. Good job. Any questions here? All right, number 10. What should I do here?
I mean, multiply by
The conjugate?
yeah.
Perfect. I'm going to multiply by the conjugate. When you have 1 minus a trig function, if it was something that if it was a reciprocal function like cosecant, I might change the 1 to be like cosecant over secant and find a common denominator. But since it's sine, I'm going to multiply by the conjugate. So the conjugate here would be 1 plus sine. So whatever I do on the bottom, I have to do on the top. 1 plus sine. So on the bottom, I'm going to FOIL it out. So I have 1 plus sine minus sine minus sine squared. Awesome. The 2 sines cancel. On the top, I just have cosine times 1 plus sine. I'm not going to distribute it out yet, just in case I get something to cancel. So before I distribute, I'm going to keep it like this in case I see something. So on the bottom, I now have 1 minus sine squared. What can I do next? I could do that, or I could change 1 minus sine squared to be cosine squared. because you canceled them out, right? So cosine squareds, if I have one on the top and on the bottom, they'll cancel. So then here I'm just left with 1 plus sine. Done. If I had, let's say, cosine squared times 1 plus sine over 1 minus sine squared, you can't cancel these because they're different. So because I have a sine squared on the bottom, you can't just cancel them. If it was, also because one's a plus and one's a minus, so you can't cancel them. If this was 1 minus sine and 1 minus sine, if they're the same exact thing, then you could cancel. But they have to be the same exact thing. All right, let's look at 11. What should I do first for 11? I could use one of my Pythagorean identities and make secant squared minus 1 tangent squared. So I have tangent squared over secant squared. What can I do next? Change it all to be in terms of sine and cosine. So I have sine squared over cosine squared over 1 over cosine squared. Keep, change, flip. So keep the top, change the multiplication, flip the bottom. So this would be cosine squared over 1. I'm multiplying a cosine squared on the top and on the bottom so they can cancel. So what am I left with? Sine squared. And that's it. So if we wanted to, just as another example, we could break it up so it would be secant squared over secant squared minus 1 over secant squared. So since I'm subtracting, they each get the denominator. This would be 1 minus cosine squared, which is sine squared. So just another way to do that. All right, last one, number 12. This sine squared should have a theta after it. But what can I do here? Factor it. Awesome. Since I have a sine squared and a sine and a constant, I can factor. So you can think about this as x squared minus 2x plus 1. Do I have two factors of 1 that add to negative 2? Negative 1, negative 1. So this would be x minus 1 times x minus 1. But since I just replaced sine with x, I have to make sure I plug sine back in. So this would be sine theta minus 1 and sine theta minus 1. Or you could write it as sine minus 1 squared, because it's the same thing.
Why would it, if you...
So the answer would either be this one or this one, because they're the same. So I'm going to want to work with the left side since it's more complicated. What should I do first? Awesome. On the left side, I'm multiplying and I'm adding, so I have a lot of terms going on, and I know eventually I'm going to get this to simplify to 1. So I want to condense the 1 plus cotangent squared, which I know that that's one of my identities. My identity is 1 plus cotangent squared is equal to cosecant squared. So I'm going to take cosecant and substitute that in for 1 plus cotangent. So I have sine squared times cosecant squared. What can I do next? Cosecant is 1 over cosine, so this would be 1 over sine squared. So if I'm multiplying, I get sine squared on the top and sine squared on the bottom, so they'll cancel out. So then I'm just left with 1 is equal to 1. Any suggestions on how I should start here?
Can we work on the right side?
We could do that.
So switch tan squared theta to sine squared theta.
Okay, so make tangent squared sine squared over cosine squared.
Yeah,
Okay, so sine squared would be sine over 1. So a common denominator, I have to multiply the top and the bottom by cosine squared. So then on the top, I have sine squared minus sine squared times cosine squared over cosine squared on the bottom.
And now you pull out a GCF of sine squared theta.
Awesome, I can take out a GCF on the top, so I'm going to take out a sine squared. And then what am I left with when I take out sine squared? 1 minus cosine squared over cosine squared.
So then I use an identity for 1 minus cosine squared theta, and then change it to sine squared theta.
Awesome, our Pythagorean identity here is sine squared plus cosine squared equals 1. So I want to make this look like 1 minus cosine squared, so I'm going to subtract cosine squared on both sides. So sine squared is equal to 1 minus cosine squared. So I'm going to take sine squared and substitute it in for that 1 minus cosine squared. So I have sine squared times sine squared over cosine squared.
And then I split those up to 2 different fractions with sine squared theta over cosine squared theta, and sine squared theta over 1.
Okay, so in multiplying, I can break it up. So sine squared over cosine squared times sine squared over 1. Careful when breaking this up that you don't put 2 cosine squareds on the bottom, because then when you multiply it together, you would have cosine to the 4th power. So the cosine squared went to the left side, and the right fraction just has a 1 on the bottom. When adding, they both get the same denominator, but when multiplying the denominator, you could either break it up into a cosine and cosine or put it on one side.
So then,
Logan, did you have a question? Amber, what'd you do next?
and then I just use the identity for tangent squared theta.
So that's tangent squared times sine squared, which is our answer here. Awesome. Good job. All right, 17. I'm going to want to work with the left side here since it's more complicated. What can I do first? Awesome. So I'm going to change everything to be in terms of sine and cosine. And then tangent would be sine over cosine over cosine over sine. So here, be careful when you keep change flipped. A lot of people made this 1 over or 1 minus 1 because they thought that the cosines canceled. Just be careful. If you keep the top, change to multiplication, and flip the bottom is cosine over 1, so when you flip it, it's 1 over cosine. So when you multiply this, you get 1 over cosine squared. So be careful. And then on the right side, we keep change flip also. Is that what you did, Logan? Okay. So then keep the top, change to multiplication, flip the bottom to be sine over cosine. So then when we multiply those together, we get sine squared over cosine squared. What can I do next? Awesome. They have the same denominator, so I'm going to make it 1 minus sine squared over cosine squared. Perfect. Our Pythagorean identity we use here is sine squared minus cosine squared equals 1. Sine squared plus cosine squared equals 1. So then to make this look like 1 minus sine squared, I have cosine squared is equal to 1 minus sine squared. So I'm going to take cosine squared and substitute it in there. So I end up with cosine squared over cosine squared, which is 1, which is my goal. Okay, we can FOIL the left side. So we have sine times tangent, which would just be sine times tangent. Then sine times cotangent plus cosine times tangent plus cosine times cotangent. What can I do next?
Get everything in cosine.
Okay, I can do that. I can change everything to be in terms of sine and cosine. So tangent, I'm just going to change it here, would be sine over cosine. So when multiplying this, I get sine squared over cosine. Cotangent becomes cosine over sine. So the sine on top cancels out with the sine on the bottom. So this is just cosine here. Tangent becomes sine over cosine. So the cosine on top cancels out with the cosine on the bottom. So this would just be sine. And then for our last one here, cotangent is cosine over sine. So when we multiply these together, we get cosine squared over sine. Now from this point, you may not know what to do next. So a suggestion would be maybe take a look at the right side and see if we can get it to look like something else to kind of give us a hint on what we need. So secant is 1 over cosine, and then cosecant is 1 over sine. So I know I'm going to need 2 fractions on the left side, and one's going to have the denominator of cosine and one's going to have the denominator of sine, which I almost am there kind of, but I have a little bit more going on. So what could I do next?
So, I guess we're trying to make the cosine like squared and the sine squared so we can get an identity. So do a common denominator maybe?
A common denominator with everything?
The 2 in the right and the 2 in the gray.
Awesome. So with these two, I can get a common denominator. So the cosine here, I can multiply it by cosine over cosine. So that would give me sine squared plus cosine squared over cosine. Did you do the same thing with the green one?
Yeah.
So here I want my denominator to be sine. So I'm going to multiply the sine theta times sine over sine. So I would have sine squared plus cosine squared over sine. We know what sine squared plus cosine squared is because that's our identity. So we know sine squared plus cosine squared is equal to 1. So I can substitute 1 into this sine squared plus cosine squared and this one here too. So I have 1 over cosine plus 1 over sine, which is what I wanted here. If you didn't do anything on the right side and you got to 1 over cosine plus 1 over sine, then you would just change it to secant plus cosecant and then set it equal. So you can work with both sides, just make sure you get one side is equal to the other side. My suggestions for tomorrow is always try something. Do not look at it and be like, I don't know where to start. Even changing everything in terms of sine and cosine will get you some type of points. So always try something when doing these. See if you have anything squared, use an identity. Always do something.